Hi everyone, I am Gauri PS, lecturer, Department of Radiology, Global College of Allied Health Sciences. Today we are going to discuss about the topic nuclear fission. First, neutrons are the uncharged particles which have an advantage of penetrating through the nucleus without being accelerated to high energy. And the nuclear reactor uses the two methods to produce radionuclides as nuclear fission and by nuclear neutron activation. The radionuclides which are obtained from the fission process are molybdenum 99, iodine 131, xenon 133. These will be separated from other fission products. So they are said to be carrier free since they have no stable isotope in them. So their specific activity will be higher, that is very much required for radiopharmaceutical preparation. First, nuclear fission. And nuclear fission is the splitting of a heavy nucleus into two lighter nuclei with the release of energy. If a neutron bombards high atomic nuclei, the nuclei will be splitting into nuclei of lower atomic number with additional neutrons. This process of production of nuclei is called as fission process. That is, uh, the energy will be released during the fission process and will be appear as a form of kinetic energy of the product particles. And next is about the history. It was first discovered by Otto Hahn and Fritz Strassmann in 1938, and this was explained by Lise Meitner and Otto French. The basic principle of the nuclear fission is about a heavy nucleus will be absorbing a neutron and it will be becoming unstable. That is the basic principle just followed in the nuclear fission process. Usually in a fission process, the unstable nucleus will be splitting into two fragments and will be releasing the neutrons and also the energy particles from there. That is, for example, uranium 235, when interacting with a neutron, it will be giving out uranium 236 and it on again further fission reaction, it will be converting into barium 141 and krypton 92 with the releasing of three neutron particles and a large amount of energy. This energy released will be appearing in a form of the kinetic energy of the product particles. The next is about fissionable materials. What are fissionable materials? Fissionable materials that will be undergoing several fission products or fission reactions. So fission reaction or the fissionable materials we will be saying it as uranium 235, plutonium 239 and uranium 233. Next is about mass defect. The mass defect is the difference in mass that is converted into energy based on the Einstein equation is equal to mc square. The energy released per fission reaction will be about around 200 mega electron volt. Next is about chain reaction. During the fission reaction, 2 or 3 neutrons will be emitted with the addition with the fission fragments, and these neutrons in turn will be inducing a fission in other uranium 235 nuclei that will be in the releasing of the additional electrons. Thus, a number of fissions which takes place at each successive stages and will be going on increasing at a rapid rate and it will be giving rise to a chain reaction. So this reaction will be set up only if the mass of the fissionable material will be greater than the critical mass. Hence, controlled chain reaction will be only used in the nuclear reactors. That is, in a chain reaction, the releasing of neutrons will be caused by due to the further fission reactions. There is usually two types, that is about controlled chain reaction and uncontrolled chain reaction. In controlled reaction, it will be occurring in the nuclear reactors by the means of a control rods, And uncontrolled chain reactions will be occurring in the nuclear weapons, that is, it will be producing a rapid energy within the release of from the particle. Next is about the nuclear reactor, and the nuclear reactor consists of a major five components, that is about fuel, moderator, or control rods, coolant, and also about the shielding. Usually the moderators we used will be is used to slow down the functioning of the neutrons. That is, the materials which slow down the process of the neutrons will be called as the moderator, and we commonly used graphite and heavy water as the moderator. And the control rods, then control rods will be using a material that will be absorbing the excess amount of neutrons which are produced. So most commonly the we used control rod is about cadmium or boron. Next is about coolant, and coolant is about a material which gives a cooling effect due to the system, as there is a large amount of heat is produced from there. Next is about shielding. A proper shielding should be maintained. Otherwise, the nuclear reactors may blast at any time due to the continuous production of heat over there. Next is about application. Usually, it is applied in the case of electricity generation, isotope production, and also in the cases of researchers. The advantages of this nuclear fission reactor is that it will be producing a high energy output and will be has a low greenhouse gas emissions. It also has a disadvantages, that is about it produces a large amount of radioactive wastes, and there are accidental risk, and it is mainly higher in cost in comparing with other systems. What are the safety precautions which has to be done? It should be a containment structure, that is, it has many compartments so that the production of this fission products should not react with any of the persons or anyone nearby, and should have a proper shielding, that is, as due to the reaction there will be many types of radiation which is produced from there, and this radiations will be harmful to our body, so it has to be properly shielded so that it does not affect anyone surrounding there, and there should be a monitoring devices, that is, it will be monitored the amount of radiation or the substance which is produced from the nuclear reactors. When we compare this fission with the fusion, fission will be splitting the heavy nuclei, whereas the fusion will be combining the lighter nuclei. So from this summary, we can understand that the nuclear fission has a major role of energy, as a major source of energy, and is a best topic in radiation physics. And that's all for today's class. Thank you.